In this lecture, we're going to dive into debugging Python programs in VS Code. Debugging is an essential skill for every programmer because, no matter how careful we are, errors will always sneak into our code. But with the right tools and techniques, we can catch and fix them efficiently. We'll focus on how to set up and use the debugging tools in Python, which will help us spot logical errors in our code. Let's start by installing the Python extension and debugger in VS Code. If you haven't done so already, open VS Code and navigate to the Extensions tab on the left. In the search bar, type Python and install the Python extension by Microsoft. After installing, it's helpful to check which extensions are currently enabled. We can do this by going to the Extensions view and filtering to show only enabled extensions. You'll notice that along with the Python extension, both Pylance and the Python debugger have been automatically installed. Pylance provides advanced language features like smart autocompletion and type checking, enhancing our coding experience. The Python debugger integrates seamlessly with VS Code, giving us powerful debugging capabilities right out of the box. Now, you're ready to debug Python code directly within VS Code. Next, let's talk about setting up the debug configuration. Once the extension is installed, we need to set up how our code will run in the debugger. Click on the Run and Debug icon on the left panel, then select Create a Launch.json file. In the menu that opens, select Python Debugger. Next, choose Python File, which tells VS Code to debug the currently active Python file. After this, you'll see the generated JSON configuration file, which will be stored in the .vs code folder in the root of your project directory. This file contains the settings for how VS Code will run your debugging sessions. For most cases, the default configuration should be enough, but it's good to know where to adjust settings if you ever need to. Now let's create a new Python program to practice debugging. For that, I'll create a new folder and name it Debug. Then I'll add a file called debugexample.py. In the file, I'll start by defining a function named calculateTotal. This function will take one argument, which is a list of numbers. We'll begin by initializing a variable called total to 0. This variable will hold the sum of the numbers as we go through the list. Then we'll use a for loop to iterate over each number in the list, and for each iteration we'll add the number to total. Finally, after the loop finishes, the function will return the total sum. So, the function simply adds up all the numbers in the list and gives us the final total. Now let's use the function we just wrote. I'll create a list of numbers and store it in a variable called numbers. Next, I'll call the calculateTotal function with this list as the argument and store the result in a variable called result. Finally, we'll use a print statement to display the total. Let's firstly run the code and make sure it works as expected. We need to go to the Run and Debug view and hit the Start Debugging button. It reports a total of 10, which is correct. Note that the shortcut for jumping to the Run and Debug view is Ctrl-Shift-D. Now let's introduce an intentional error to see how debugging can help us. I'll change the number 3 in our list to the string 3. This will cause a type issue when we try to add it to the other numbers because Python can't add a string and an integer together. This type error will help us demonstrate the power of debugging tools. So, our list will now look like this. Let's run the whole code and see what happens. We get an error report like this. Although this error message clearly tells us the issue, that we're trying to add an integer and a string together, let's take it a step further. Instead of just relying on the error message, we'll use the debugger to run the program line by line, inspecting the variables and finding the cause of the error in a more interactive way. This approach can be really helpful, especially in more complex scenarios where the cause of the error isn't immediately obvious. Instead of running the entire code at once, we'll set a breakpoint to pause the program at a specific line before the error occurs. This will allow us to stop the execution and inspect the state of the program step by step. By doing this, we can see what's happening in the numbers list and catch where things go wrong before the program crashes. Now, let's add a breakpoint. I'll click on the line number where we are starting the for loop right before the error happens. A red dot will appear, indicating that the debugger will stop at this line when we run the code. With the breakpoint in place, we can start debugging and step through the code, line by line, to observe how the numbers list is processed. This will give us the opportunity to see when the program tries to add the string 3 to the total, helping us catch the exact moment when the error occurs. Now let's start debugging. Note that the shortcut for Start Debugging is F5, so once we've set our breakpoints, we can quickly start the debugging process by pressing this key. This will begin executing the code, and it will pause at the breakpoint we set. As we enter the debugging process, you'll notice a set of buttons at the top that help us control the flow of the program during debugging. Let's go over what each of these buttons does. The Continue button, or F5, resumes the program's execution until it hits the next breakpoint. It's useful when you want to skip over parts of the code you're not interested in right now. The Step Over button, or F10, moves to the next line of code without stepping into any functions. It's perfect for cases where you want to see how the main flow of your program progresses without getting into function details. The Step Into button, or F11, takes you inside the function calls. If you want to investigate what's happening inside a function, use this to dive into its code. If you've stepped into a function and now want to return to the outer level, use the Step Out button, or Shift F11, to exit the current function and continue the flow in the main code. The Restart button, or Control Shift F5, will restart the program from the beginning, which can be handy if you want to reset and rerun the code after making some changes. Finally, the Stop button, or Shift F5, stops the debugging session altogether if you're done or want to quit. Now that we understand the debugging tools and what each button does, let's get back to our debug process. With our breakpoint in place and the Start Debugging command initiated, we can now step through the code using these buttons to inspect how each line is executed. Let's take a closer look at the Variables section, which appears in the Debug panel. Here, we can see all the variables currently in scope, including their names and values. In our case, we can see the numbers list and the total variable, which is initialized to 0. As we move through the code line by line, we can observe how the values of these variables change. When we step into the loop, the value of num will change with each iteration, and you'll see it updates in the Variables section. Now let's focus on the Watch section. This is a helpful tool that allows us to track specific variables or expressions throughout the debugging session. To add a variable to watch, right-click on a variable in the code, like num, and select Add to Watch. The variable will then appear in the Watch window, and we can monitor its value as the program runs. This is especially useful when you want to keep an eye on a critical variable without manually checking it every time. As we step through the code, pay attention to how num changes with each iteration. I press Step Over to execute this line. Since this line doesn't contain a function call, there's no difference between using Step Over and Step Into. Both will simply move to the next line in the code. As a result, total changes from 0 to 1. With another step over, num becomes 2. Again, I hit Step Over, and this time total adds num to itself and becomes 3. With one more step over, num becomes the next item in the list, which is 3, a string. This is the moment of truth. If I try to add this string to total by hitting another step over, it will cause an error. So this is the root of our problem, and now we can fix it. Keep in mind that you can toggle a breakpoint by clicking on the line number where you want to pause the code. I remove this breakpoint and add another one here, just to explore. So after making the correction, I'll hit the Start Debugging button to run the program again until it reaches the first breakpoint. Note that we could also hover over num and total variables to see their current values at any point during the debugging process. Let's explore 2 more techniques that are useful in our debugging process. First, we can evaluate expressions while the code is paused. For example, we can create a custom expression like num times 2 plus 5 and enter it into the watch window. This allows us to see the result of this calculation without modifying the code. It's a great way to quickly check how different values or operations behave during execution. Second, we can modify the value of a variable directly while debugging. This can be done by going to the Variables section, right-clicking on the variable, such as num, and selecting Set Value. For instance, I'll change num from 1 to 10 and do a step over. You'll see how this modification affects our total variable. In the previous example, we could change num from 3, the string, to 3, the integer, to see how the program behaves with the corrected value. This is helpful when testing different scenarios without having to stop and rewrite the code. These 2 techniques give us more flexibility in investigating and fixing issues during debugging. Now, as a final test, let's disable all breakpoints and restart the process to make sure the program runs smoothly. The total is 10, as anticipated. Disabling breakpoints offers the benefit of keeping them in place for future use, without needing to remove and re-add them. Let's summarize what we covered in this lecture. First, we learned how to install the Python extension and debugger in VS Code. Then, we discussed setting up a debug configuration and adding breakpoints to pause our code. We explored how to use debugging controls like stepping through code, inspecting variables, and evaluating expressions. We also used watch expressions and modified variables to help track down and find the error in our code. That's it for debugging. Debugging might seem tricky at first, but with practice it becomes second nature. Now you're equipped to find and fix errors in your Python code.